We have an all-new battery pack. And then something we're really proud of is the new carbon-sleeved rotors for the motor. So this is the first time that...
Have you ever stopped to wonder what it would look like if a single company suddenly leapt so far past everything the electric vehicle world has ever built that it wasn't just ahead by one step or even one generation, but so far out in front that every other automaker had to stop and ask, wait, who exactly are we even racing against anymore? A few weeks back, when Elon Musk walked out on stage to unveil Tesla's newest electric motor, most people figured it would be business as usual. A launch event, some impressive stats, a round of applause, and then life would go back to normal. Except this time, it didn't play out that way at all. What Tesla showed off wasn't just a lighter or more powerful motor. It was a total rewrite of what an electric motor is even capable of. A rotor wrapped in carbon fiber spinning past 20,000 RPM, powering a car that can go from 0 to 60 in under 2 seconds. With that one reveal, Tesla dragged the entire EV industry into a different league, and most of its rivals haven't even caught up to that reality yet. Here's the part that really makes you think, though. Tesla isn't keeping any of this a secret. They published the patents for anyone to see. Any car maker on Earth can pull them up, study them, even try to replicate them. So why doesn't that erase Tesla's edge? How can you hand someone the recipe and still watch them fail to cook the dish? And what does this mean for the millions of people out there weighing whether to buy an EV in the next few years? Can the rest of the industry close the gap, or are we watching Tesla quietly become the undisputed king of this space? That's exactly what we're digging into today, and I promise the deeper we go, the stranger and more interesting this story gets. Before we jump in, if you're into deep dive videos like this one, ones that don't just repeat headlines but actually explain why something matters and how it changes the bigger picture, go ahead and hit subscribe. Elon Musk turned a wild idea into a global disruption. To really understand why this new motor is causing such a stir, we have to rewind. Not just a couple of years, but nearly 2 decades. Back in 2003, when Martin Eberhard and Mark Tarpenning started Tesla Motors out of San Carlos, California, the rest of the auto world basically laughed it off. Electric cars at the time, on the rare occasion they existed, were basically glorified golf carts with windows bolted on. No real power, barely any range, and nobody was picturing themselves cruising down the highway in one. The notion that an electric vehicle could ever go toe-to-toe with a gas car on performance, styling, or the actual feel of driving was written off by nearly every industry insider. Not a single major manufacturer wanted anything to do with that bet. Then, Elon Musk showed up. When he invested in Tesla in 2004 and became its biggest shareholder, he didn't just bring cash to the table. He brought an entirely new vision of what an electric car could be. Not a niche product for eco-conscious buyers or people trying to save on gas, but in Musk's mind, it needed to be the fastest, most beautiful, most thrilling machine you'd ever climbed into. In 2008, Tesla rolled out the original Roadster. Built on a Lotus platform, it was quicker than most gas-powered sports cars in its class, and it proved something huge. An electric motor really could deliver serious power. Not power that only looked good on a spec sheet, but power you could actually feel slamming you back into your seat. Then came the Model S in 2012, a full luxury sedan packing a massive touchscreen, over-the-air updates, and enough raw performance to make BMW and Mercedes squirm. After that, the Model X arrived with its Falcon wing doors, followed by the more budget-friendly Model 3, which finally opened the door to everyday buyers. Then the Model Y, and eventually the Cybertruck. Looking like something out of a crashed spaceship. Every single release sent shockwaves through the industry. The legacy automakers scrambled to launch their own EVs. Ford put out the Mustang Mach-E. GM sank billions into its Ultium platform. Volkswagen rolled out its ID lineup. Hyundai and Kia suddenly turned into serious contenders in the EV space. At that point, a lot of experts were convinced Tesla had already peaked. that its best days were behind it, and once the major players truly entered the fight, Tesla wouldn't stand out anymore. They were wrong. Because while everyone else was busy trying to catch up to what Tesla had already accomplished, Tesla was quietly gearing up for its next move, one that almost nobody in the industry saw coming. But to understand why this leap matters so much, we need to zoom in on what's actually happening inside the motor that's shaking up the world. When Musk walked out and revealed the new Plaid motor with its carbon sleeve, a lot of people's gut reaction was, okay, cool, but is it actually that different? The answer is yes, and the difference runs a lot deeper than what's visible on the surface. Let's start with the rotor, the spinning core of every electric motor that turns electrical energy into physical motion. In most electric motors on the road today, that rotor is built from copper and steel alloys. Those materials have done the job for decades, but they hit a hard physical ceiling. As rotational speed climbs, the centrifugal force on the rotor grows exponentially. Past a certain point, the material starts to warp. Heat builds up, precision drops, and the whole system loses efficiency right when it's needed most. Tesla tackled this with an idea that sounds simple, but is brutally hard to pull off in practice, wrapping the rotor in carbon fiber. Carbon fiber, the same stuff you'll find in Formula One cars, aircraft, and spacecraft, has a far better stiffness-to-weight ratio than steel. It's lighter, stiffer, and handles high-speed tension dramatically better. When Tesla wraps this layer around the rotor, it creates an outward compressive force known as preload, which keeps the rotor's structure locked in place even at extreme speeds. The payoff? Tesla's rotor can spin past 20,000 RPM, a number most conventional motors never come close to touching. And that spin speed translates directly into the acceleration and power you feel behind the wheel, which is exactly why the Model S Plaid hit 60 mph in under 2 seconds. Until recently, that kind of number only showed up in million-dollar hypercars like Bugatti or Koenigsegg. Tesla just stuffed it into a family sedan, but speed is really only half the story. The bigger deal here is energy efficiency. Since the rotor weighs less, the motor needs less power to spin it. That means the same battery charge takes you farther. It means the cooling system doesn't have to work as hard. It means the battery itself can last longer. All of these benefits stack on top of each other and feed into a positive loop: a leaner motor, a healthier battery, longer range, and lower running costs. There's also a factor people tend to overlook: thermal stability. In a typical motor, heat is the enemy. As temperatures rise, metal expands unevenly, creating tiny imbalances inside the motor that wear it down over time and chip away at performance. Tesla's carbon sleeve doesn't expand the same way. It holds a consistent compressive grip no matter how hot things get, keeping the rotor steady under any operating condition. In short, this isn't just Tesla's fastest motor ever, it's also the most durable, the most stable, and the most efficient, all rolled into one design. It sounds like a small tweak on paper, but that small tweak might be exactly what changes everything. The real secret is hiding in the last place you'd look. Here's the part that genuinely blew me away when I first came across it. Wrapping carbon fiber around a metal rotor sounds simple enough in theory, but in reality, it's one of the toughest engineering puzzles Tesla has ever had to crack. Why? Because carbon fiber and metal, specifically the copper and steel in the rotor, expand and contract at completely different rates when temperatures shift. If you just slap carbon around the rotor without extremely precise calculations, the layer can peel, crack, or in the worst case, throw the whole thing wildly out of balance at 20,000 RPM. You can imagine how that ends. To get around this, Tesla had to build an entirely new AI-controlled robotic system from the ground up, one capable of applying that carbon layer with micrometer-level precision. Not millimeters, micrometers, 1,000th of a millimeter. This system manages everything simultaneously: the tension of the fiber as it's wrapped, the surrounding temperature, the wrapping speed, and the exact angle the fiber goes on at. Then it double-checks the result with laser sensors to catch even the tiniest deviation. Every single rotor gets individually inspected before it ever makes it into a motor. And here's the real kicker. Tesla patented this whole carbon sleeve process and then opened it up to the entire world. Any company can pull up the blueprint. But the blueprint isn't the machine. You can know the secret and still not have the equipment to pull it off. You don't have the AI system that's been trained through thousands of tests to know exactly how much tension is right. You don't have years of refined quality checks. And even if you somehow had all of that, you'd still need to fold it into a production line churning out tens of thousands of units a month. This is the genius of Tesla's move. Publishing the patents isn't an act of generosity. It's a flex. They're telling the world, we've gone so far ahead that even if you know every one of our secrets, you still can't catch up. But no matter how brilliant the tech is, none of it matters if it can't be built at scale. The challenges Tesla would rather you forget. Of course, nothing's perfect. If all we do is heap praise on Tesla without acknowledging the real risks, this stops being honest analysis. So let's talk straight about what Tesla is still up against. First, production cost. This micrometer precision carbon sleeve process isn't cheap. Every rotor eats up machine time, requires strict inspection, and uses pricey materials. Even as Tesla ramps up output, each plaid motor still costs noticeably more to build than a standard one. That raises the question, can this tech ever trickle down into everyday models like the Model 3 or Model Y, or will it stay locked to the high-end lineup forever? Second, financial pressure. In 2024, Tesla went through significant layoffs and faced tough questions about shrinking margins as the price war with Chinese rivals heated up. Baidsaic Neo, these aren't scrappy startups anymore. They're cranking out millions of vehicles at far lower cost and pushing hard into international markets. And in a price war, having better technology doesn't automatically win. Third, leaning too heavily on one person. Musk is undeniably a marketing genius and the strategic force behind many of Tesla's breakthroughs. But the brand being so tightly tied to him is also a liability. The controversy he stirs up online, his polarizing comments, promises that slip past their deadlines, all of it chips away at consumer trust. And for buyers over 45, people who've seen enough hype cycles to know better, trust often matters more than raw speed. Fourth, charging infrastructure. Tesla's supercharger network remains one of its biggest edges in the US, but now that Tesla is opening those chargers up to other brands, that advantage is becoming less exclusive. Meanwhile, range anxiety is still a real mental hurdle for buyers in states without dense charging coverage. Fifth, the uncertainty around self-driving. Tesla's been promising full self-driving for years now. The tech has genuinely improved, but it still hasn't hit the bar Musk once promised. That gap between expectation and reality does real damage to credibility. None of this erases what Tesla just pulled off with the plaid motor, but it's a reminder that in the real business world, the best technology doesn't guarantee a market win. A lot of other pieces have to fall into place at the same time. Which is exactly why this race keeps getting more intense, because Tesla isn't the only company chasing dominance here. The ones who refuse to back down. When Tesla announced the plaid motor and its carbon sleeve, competitors reacted in wildly different ways. Some went quiet, some brushed it off, others quietly ramped up work behind closed doors. Let's break down each group. Lucid Motors is arguably the sharpest rival on pure engineering. The Lucid Air Grand Touring Performance boasts a range past 500 miles, something Tesla's Model S still hasn't matched, and its drivetrain is genuinely impressive from a technical standpoint. But Lucid has a real problem: sales. They only build and sell a small number of cars each year, mostly aimed at the ultra-luxury crowd. That's a niche, not a revolution, and without serious revenue, they don't have the resources to develop next-gen motors at a scale that competes with Tesla. Rivian is chasing something different entirely: electric trucks and SUVs built for the outdoor crowd. They've got solid design, a loyal customer base, and financial backing from Amazon. But when it comes to raw motor technology, they're still working with a fairly conventional setup, and the gap between them and Tesla widens with every new generation. Ford might be the most interesting case among the legacy automakers. The F-150 Lightning sold reasonably well and proved Americans are open to electric trucks. But Ford still leans on outside suppliers for batteries and motors, and it's had to slash EV production targets multiple times as costs spiraled. With a business split between gas and electric, Ford simply can't go all in on new motor tech the way Tesla can. GM has poured close to $35 billion into electrification, but its Ultium platform, once billed as the foundation of its future, has run into delays and real-world rollout problems. The Cadillac Lyriq and Chevy Equinox EV are decent products, but neither has produced a wow moment on the level of what Tesla just delivered. And then there's BYD, the name Tesla needs to watch most closely. This Chinese company has now outsold Tesla globally in total EV volume and runs a tighter vertically integrated supply chain than almost anyone else, building its own batteries, chips, and key components in-house. Its production costs are dramatically lower, and it's aggressively expanding across Europe, Latin America, and Southeast Asia. Still, BYD has one big weak spot. Its brand and software ecosystem aren't strong in the US yet. American buyers, especially those over 45, still tend to trust familiar names over unknown newcomers. And until BYD can truly break into the US market at scale, something currently blocked by tariffs and trade policy, Tesla keeps its home turf advantage. Here's the bottom line. No single competitor is threatening Tesla across the board. Lucid has the engineering chops but lacks scale. BYD has the scale but not the brand power in America. Ford and GM have brand strength but lack both engineering edge and scale. Tesla, meanwhile, has all of it, plus a motor nobody else can currently replicate. So the real question becomes, is this technology genuinely powerful enough to reshape the future, when a car motor stops being just about cars? This is where the story gets bigger than any single vehicle or any single race. During the Plaid motor reveal, Musk said something that a lot of people brushed past because they were fixated on the performance numbers. He hinted that this motor, with its superior power-to-weight ratio, thermal stability, and ability to sustain high RPMs for long stretches, could have uses far beyond cars. Think about electric aviation. One of the biggest roadblocks for electric aircraft has always been the propulsion system. The motor needs to be light enough not to weigh the aircraft down, but powerful and reliable enough to fly safely. Plenty of startups are working on electric vertical takeoff and landing aircraft, and they all keep running into the same wall. Current motors are either too heavy or not efficient enough across the speed ranges required. Tesla's carbon sleeve Plaid motor could be the answer. Light, powerful, thermally stable, and able to hold high RPMs for long periods without losing performance, exactly the traits the electric aviation world is chasing. Tesla hasn't officially said it plans to license this motor to aircraft makers, but the signs are already pointing in that direction. If it happens, Tesla stops being just a car company and becomes a hardware supplier for an entire energy revolution. Think about energy infrastructure too. Wind turbines, industrial pumps, large-scale storage systems, all of them need highly efficient motors that can handle harsh conditions. If Tesla can mass-produce Plaid motors at steadily falling costs thanks to economies of scale, it could end up supplying motors for the whole clean energy economy, from cars to planes to the power grid itself. This isn't science fiction, it's the logical next step for a company that already runs gigafactories on 3 continents, builds megapack batteries for national grids, and powers homes through Powerwall solar systems. Tesla isn't just an EV maker anymore. It's turning into an energy and mobility platform for this century. While the rest of the auto industry is busy trying to build a good electric car, Tesla is trying to build the infrastructure for a world that no longer runs on fossil fuels. Those are 2 completely different games in scale and ambition. And then there's the long-delayed Roadster 2.0, the electric sports car Tesla has promised and pushed back more times than anyone can count. It might end up being the ultimate proving ground for everything this new motor can do. If it lands with the promised specs, under 1 second from 0 to 60, over 600 miles of range. And the full application of this latest motor tech, it won't just be a fast car. It'll be the boldest technological statement any automaker has ever made. The game isn't over, but Tesla is once again rewriting it from scratch. So we've traveled a long road here, from the original Roadster in 2008 to a motor wrapped in carbon fiber with micrometer precision today. But I want to pause and talk directly to you about the most important part of everything we've covered. Tesla's plaid motor tech is real. The numbers are real. The gap between Tesla and its rivals in motor engineering, at least right now, is real. But history has taught us again and again that a technical edge doesn't automatically decide who wins commercially. Betamax was technically superior to VH, and VH still won. BlackBerry had a better physical keyboard than any touchscreen phone of its era, and the iPhone changed everything anyway. Nokia ruled the phone market for years before nearly disappearing overnight. The EV market is still taking shape. Consumers are getting savvier. Government incentives can shift. Battery prices are dropping fast, which can erode anyone's cost advantage. And in a shifting geopolitical climate, decisions on supply chains and tariffs could reshape this entire race in ways nobody can predict. So yes, Tesla has just done something remarkable with this new motor. But is this really the beginning of the end for the rest of the EV industry? Are competitors truly unable to catch up, or are some of them quietly cooking up breakthroughs of their own that we haven't heard about yet? Honestly, I don't know, and you should be skeptical of anyone who claims they do. What I do know is this. Right now, the EV industry is defined by fierce competition, technical leaps, price wars, and an infrastructure race. And all of it is shaping the future of transportation worldwide. What plays out over the next 3 to 5 years could define this industry for decades. So, what do you think? Has Tesla really closed out the game with this new motor, or can rivals from Lucid to Bide to names we haven't even heard of yet still pull off a surprise? I'd genuinely love to hear your take. Drop a comment below, especially if you own a Tesla or are considering an EV purchase. Those are the perspectives that matter most here. If this video gave you a fresh way of looking at the EV revolution, hit like so it reaches more people. And if you want more deep dives like this, not just on Tesla, but on the whole shifting landscape of tech and energy, subscribe to the channel. Picture an ordinary morning. You wake up, grab your coffee, walk to the garage, and plug in your electric car before heading to work. 15 minutes later, barely enough time to finish the newspaper, your car's fully charged. You drive 500 miles without a single stop. No fear of running dry, no worry about your car's value tanking after a few years. Even after 15 years of use, the battery still feels close to new. Sounds like science fiction? It's not, and Tesla is promising to make this a reality, not just a talking point. For years, people assumed traditional lithium-ion batteries were basically at their ceiling, that we were already near the limits of what battery chemistry could achieve, and that the next real leap was still 2 or 3 decades away. But things are moving faster than anyone predicted. In early 2025, Tesla quietly rolled out a series of technical shifts that, according to industry analysts, could mark the biggest turning point in EV battery history since the first Model S hit the road back in 2012. This isn't a minor tweak or a routine optimization, it's a fundamentally different approach to the battery problem, touching everything from materials to structure to how the batteries are actually manufactured. Meanwhile, on the other side of the Pacific, Bide, the Chinese giant that's outsold Tesla for several quarters running, suddenly found itself facing a rival that wasn't just keeping pace anymore, but pulling ahead with a genuinely different kind of breakthrough. So what exactly makes Tesla's new battery tech so significant that the whole industry has to pay attention? Why is Bide, long seen as the dominant force in global EVs, suddenly feeling the heat? And is this really the turning point that reshapes the entire auto industry, or just another case of Musk overselling what engineering can deliver? Before we go further, if you're into detailed breakdowns like this on tech and EVs, subscribe and turn on notifications. What's coming next in this industry is something you won't want to miss. Where does the battery world stand right now, and why does it need a shakeup? To understand why Tesla's new tech matters so much, we need to zoom out and look at the broader EV battery landscape, and honestly, it isn't all pretty. EVs have exploded over the last decade, with global sales climbing from under 1 million vehicles in 2015 to more than 14 million in 2023. But behind that growth sit stubborn problems the industry still hasn't cracked. Problem 1. Driving range. Even with real progress, most EVs still trigger range anxiety, the fear of running out of juice mid-trip. For Americans in suburban or rural areas, where daily driving can stretch hundreds of miles and charging stations remain sparse, that's not a small concern. Problem 2. Charging time. Fast charging tech has improved, but going from 20% to 80% still takes at least 20 to 30 minutes even on the fastest systems available. Compare that to 5 minutes at a gas pump and there's still a noticeable gap in user experience. Problem 3. Talked about less but just as critical, battery degradation. An EV after 8 to 10 years might lose 20 to 30% of its original battery capacity. That doesn't just cut into range, it stirs up worries about resale value, a sensitive topic for American buyers used to gas cars holding their value reasonably well over time. Problem 4. Cost. Batteries make up roughly 30 to 40% of an EV's total price tag. For EVs to genuinely compete with gas cars in the sub-$35,000 range, the industry needs to slash battery costs to a level nobody has sustainably hit yet. These 4 problems are exactly what hundreds of companies, thousands of scientists, and billions in investment dollars are grinding away at every single day. Which is exactly why, when Tesla says it's found a new path forward, the whole world listens. But to really understand why this matters, we need to look at the heart of the story, what Tesla is calling its next-generation battery. Tesla's new battery tech isn't just a better battery pack. You've probably heard the term solid-state battery tossed around in videos and articles before. It sounds familiar, but don't assume this is the exact same thing you've heard about in the past. First, let's understand why traditional lithium-ion batteries, the kind in nearly every EV today, hit their limits. Inside a normal lithium-ion cell, lithium ions travel through a liquid electrolyte to generate current. That liquid has issues. It's flammable, it degrades over time, and it becomes less effective as temperatures swing. That's why EV batteries perform worse in winter and why they gradually lose capacity after hundreds of charge cycles. A solid-state battery swaps that liquid out for a solid material, usually ceramic or a specialized polymer. In theory, that means much higher energy density, longer life, better safety, and stronger performance across a wider range of temperatures. Sounds straightforward, but the industry has spent almost 2 decades struggling to make solid-state batteries commercially viable. The core issue: repeated charging and discharging causes the contact between the solid electrolyte and the electrode to break down, forming tiny cracks that slowly rob the battery of its ability to conduct electricity. Tesla isn't the first to recognize this problem, but it may be the first to solve it at an industrial scale. Based on patents Tesla filed in 2024 and 2025, along with reports from several industry sources, Tesla appears to be using what's called a dry electrode process, paired with a new generation of sulfide-based solid electrolyte material. This doesn't just fix the durability issue, and this is the crucial part, it also allows for significantly cheaper production. While most competitors build solid-state batteries using a wet process that relies on expensive, complicated chemical solvents, Tesla's dry process skips that step entirely, resulting in a leaner, cheaper, faster production line. Here's the interesting twist, though. Tesla didn't invent the dry electrode process. It acquired the tech from a small company called Maxwell Technologies back in 2019, and it spent nearly 6 years turning that lab stage process into something that can be mass-produced. So what did those 6 years actually produce? It might sound like a minor detail, but that detail could be exactly what flips the entire game, the real breakthrough. 3 numbers that shook the industry. To grasp why this technology matters, look at the 3 benchmarks Tesla is chasing and compare them to where things stand today. Number 1. 500 watt-hours per kilogram. Energy density. How much energy you can pack into a kilogram of battery is the single most important metric in EV batteries. Today's best lithium-ion batteries hit around 250 to 300 Wh/kg. Tesla's new solid-state generation is targeting 500 Wh/kg, nearly double. In practical terms, a car with the same battery weight could travel twice as far, or the same range could be achieved with a battery pack half as heavy, making the car lighter, more efficient, and cheaper to build. Number 2, a full charge in 15 minutes. If Tesla pulls this off, it could wipe out one of the last real hesitations people have about switching to EVs. Solid-state batteries can charge much faster than liquid-based ones because they don't overheat the same way. Tesla is targeting a 10% to 90% charge in 15 minutes using a 350 kW power source, already standard at many supercharger stations. Number 3, a million-mile lifespan. This might be the most jaw-dropping figure of all. A standard lithium-ion battery is rated for around 500 to 1,000 charge cycles before its capacity drops to 80%. Tesla claims its new battery can handle over 3,000 cycles, equivalent to more than 1 million miles of driving. That's not just useful for personal cars, it opens the door for trucks, buses, and especially robo-taxis, vehicles that run non-stop 24/7. But numbers alone don't tell the full story. What matters just as much is whether this can actually be manufactured at scale. Gigafactories and the mass production challenge. This is where Tesla holds an advantage that doesn't get talked about enough: manufacturing infrastructure. Tesla runs Gigafactory Nevada, the largest battery plant in the world by floor space, alongside gigafactories in Texas, Berlin, and Shanghai. These aren't just production sites, they function as industrial-scale labs where Tesla is constantly refining its processes. The dry electrode process doesn't need the ultra-expensive clean rooms or toxic chemical solvents that traditional battery production requires, which means that as Tesla scales up, costs don't climb in a straight line, they follow a learning curve instead. Musk has said many times that the hardest part isn't designing the product, it's designing the factory that builds the product. In this case, Tesla has had 6 years to design both simultaneously. According to several industry analysts, if Tesla hits its target cost of $60 per kWh for its new battery, compared to the current $100 to $120 per kWh for top-tier lithium-ion, the production cost of a Model 3 or Model Y could drop below $30,000 while still turning a profit. That's the threshold the entire EV industry is racing toward. At this point, you might be wondering, why hasn't anyone done this already? The answer? People have tried, and most have failed. Let's be upfront about the challenges Tesla still faces. Challenge 1. The dry electrode process still isn't fully stable at large scale. Tesla has admitted in several quarterly reports that scaling this beyond pilot production has been harder than expected. In 2023, it aimed to produce 100 gigawatt-hours of new generation batteries by year's end and fell well short. Not the first deadline Tesla has missed. Challenge 2. Sulfide electrolyte materials are sensitive to moisture. Exposure to regular air can damage them, which means Tesla needs an ultra-dry manufacturing environment, expensive and hard to maintain at industrial scale. Challenge 3. The dendrite problem still isn't fully solved. This is the oldest issue in solid-state battery development. Repeated charging cycles can cause tiny metallic threads called dendrites to form and pierce the solid electrolyte layer, triggering an internal short circuit and, worst case, a fire. Scientists have made huge progress reducing this, but nobody's eliminated it entirely. Challenge 4. Cold weather is still a weak spot. Even though solid-state batteries outperform liquid ones in many ways, they still lose performance in extreme cold, a real concern for buyers in northern states where winter temperatures can dip below -20°C. Challenge 5. Competition from alternative technologies. While Tesla bets on solid-state, other manufacturers are pursuing improved lithium iron phosphate batteries, sodium-ion batteries, or even aluminum-air chemistries. There's no guarantee Tesla's chosen path ends up being the winning one, and that's exactly why this race keeps intensifying. Because Tesla isn't the only one racing for the future. What are BYD, Toyota, and the other giants up to? When it comes to BYD, there's an undeniable fact to acknowledge. In 2023, for the first time ever, BYD outsold Tesla in EVs, not by a small margin either, with total sales topping 1.5 million vehicles in a single year. BYD isn't just an automaker, it builds its own batteries, specifically lithium iron phosphate cells under the Blade battery name. Blade battery has solved two major issues: safety, since it doesn't catch fire the way conventional lithium batteries can, and cost, since LFP chemistry skips cobalt and nickel entirely. But BYD isn't stopping there. In late 2024, it announced its own solid-state battery, targeting commercialization by 2027. It's also pouring resources into ultra-fast charging, specifically a 1.00-volt system that can add 400 km of range in just 5 minutes. 5 minutes. That's not a typo. So who's actually winning this race? Depends what you're measuring. By current sales, BYD's ahead. By charging infrastructure, Tesla wins. The supercharger network remains the largest and most dependable in North America. By software and AI integration, Tesla is clearly out front, with its autopilot and full self-driving systems still leading. By overall production cost, BYD holds the edge in the mid-range and budget segments. And by future battery potential, that's the biggest wildcard of all. Toyota, a surprisingly serious contender here, has invested tens of billions into solid-state batteries and says it'll have a commercial solid-state vehicle by 2027 to 2028. Toyota brings decades of manufacturing know-how and a massive dealer network, but it's often seen as slower to fully commit to electrification. Panasonic, Tesla's longtime battery partner, is building a new plant in Kansas aimed at supplying next-gen batteries to Tesla starting in 2026. QuantumScape, a Volkswagen-backed startup, is one of the most closely watched names in solid-state battery development, though it's wrestling with similar scaling issues. And in South Korea, Samsung SDI and LG Energy Solution. Two of the world's largest battery suppliers are also developing their own solid-state batteries under contract with several major automakers. This isn't a two-horse race. It's a marathon with a crowded field running on a track where the rules are still being rewritten every day. So, in the end, the biggest question remains: is this technology genuinely powerful enough to reshape the future? If Tesla pulls this off, what does the world look like? Let's walk through a hypothetical, not science fiction, just a plausible scenario set in 2028. Tesla has successfully rolled out its new solid-state battery at scale. Battery costs have dropped to $60, $70 per kWh. The base Model 3 costs $27,000 before tax. Range hits 500 miles per charge. Charging to 80% takes under 20 minutes. What happens next? For American buyers, the barrier to switching to EVs nearly vanishes. Pricing competes head-on with gas cars, range anxiety disappears, and charging time stops being a real inconvenience. According to Bloomberg NEF analysis, if this plays out, EV market share in the U.S. could top 60% by 2030 instead of the 25 to 30% currently forecast. For the oil industry, gasoline and diesel demand from transportation, currently about 40% of global oil demand, would start declining at a pace that's hard to reverse. Major oil companies have already taken notice, and many industry watchers predict peak oil demand could arrive a decade earlier than previously expected. For the power grid, the surge in EV adoption would put serious strain on national grids, especially if millions of vehicles charge simultaneously. But it also opens up an opportunity. EVs acting as mobile batteries that feed energy back to the grid during peak hours through vehicle-to-grid tech. Tesla has already tested this in Australia and parts of Europe. For BYD and Chinese competitors, if Tesla leads the solid-state race, Chinese automakers who currently benefit from low costs would face fresh competitive pressure. But don't count them out. China is investing roughly $15 billion a year in battery R&D, a figure that rivals any country on Earth. For the labor market, solid-state battery plants may demand different skill sets than traditional lithium-ion factories. That could open new opportunities for highly trained engineers and technicians while also creating a transition challenge for current battery workers. And for robo-taxis and autonomous transport, maybe the biggest, least discussed ripple effect lands here. Musk has said repeatedly that Tesla's future isn't just about selling cars, it's about running fleets of autonomous vehicles. A battery good for 1 million miles makes the robo-taxi business model far more realistic, since a single vehicle could run for years without needing a battery swap. We've covered a lot of ground, from the limits of traditional lithium-ion batteries, to Tesla's dry electrode process, to jaw-dropping numbers on energy density and lifespan, to the real technical hurdles still standing in the way, and finally, to what the future could look like if it all comes together. So what actually matters here? It's not just that Tesla is building a better battery, it's that if Tesla succeeds, the entire competitive equation across the auto industry shifts. Cost, performance, and user experience, the three things that decide market share, could all move at once, in the same direction, at a pace nobody can accurately predict. BYD knows this. Toyota knows this. Volkswagen knows this. That's exactly why they're all pouring billions into the solid-state battery race, not because they want to, but because they have no other choice if they want to survive the next decade of this industry. But let's be honest, there are still plenty of unknowns ahead. Tesla has made big promises before and missed deadlines. The Cybertruck, the new Roadster, the solar roof, full self-driving. There's no guarantee this solid-state battery arrives on schedule, or that costs fall fast enough to shift the game before BYD or Toyota close the gap. And the EV market still hinges on plenty of things outside any single company's control. Tariff policy, raw material prices, how quickly charging infrastructure gets built, and just as important, consumer habits and mindset, which shift far more slowly than technology does. One thing, though, is clearer than ever. The race has begun, and there's no turning back now. The question isn't whether EVs will eventually replace gas cars. That's basically settled. The real question is who ends up shaping the next generation of batteries and who controls the core technology behind the EV economy. And for consumers like us, people who'll be living with our car choices for the next 10 or 15 years, who should we be betting on? No single video can answer that definitively, but it's worth thinking about. So what do you think? Do you believe Tesla will actually deliver on its solid-state battery promises, or do you think BYD or someone else crosses the finish line first? Drop your thoughts in the comments. I read every one and would love to hear your take. If this video helped you out, a like is the best way to support the channel and help it reach more people. And if you haven't subscribed yet, now's a great time. This battery story is far from over, and we'll keep following it together. See you in the next one. Picture this. You're sitting in one of the most advanced electric cars on the market, the kind of car you were probably dreaming about just a few years ago, packed with the most cutting-edge tech of its time. Huge screen, powerful battery, buttery smooth acceleration. You're happy with it. You figure this is the future. Then one evening you open YouTube and catch a clip of a very familiar public figure saying, "What you're driving right now is already outdated." Elon Musk, the guy who was once mocked for claiming he'd sell tens of thousands of EVs a month. The guy who was once called crazy for saying he'd send humans back to Mars, has proven his critics wrong so many times that people have stopped betting against him lightly. So what's he hinting at this time? A completely new kind of engine technology. Not a small upgrade, not a refined version of what already exists, but an entirely different propulsion mechanism. Something that people closely following Tesla are describing as an electric jet engine. Sounds like science fiction? Maybe, but remember, lithium batteries were once science fiction too. So were self-driving cars. So was SpaceX reusing rockets, something the entire aerospace industry once considered flat-out impossible. What makes this announcement especially dangerous for Tesla's rivals isn't just the technology itself, it's the timing. While GM, Ford, Volkswagen, and dozens of other brands are dumping billions of dollars into narrowing the EV gap with Tesla, Musk seems to be preparing to rewrite the rules entirely. He's not trying to run faster on the same old track, he's trying to build a brand new track that nobody else is ready for. But here's what makes this genuinely fascinating. Nobody knows for certain how this technology actually works. Nobody knows when it'll show up on public roads, and plenty of experts are asking whether this is a real breakthrough or just another flashy stunt from a man famous for oversized promises. So what sets this technology apart from everything that came before it? Why should Tesla's rivals be genuinely worried? And could this actually be the real turning point for the global EV industry, or just another big promise waiting to be judged by time? That's exactly what we're unpacking today. Before we dive in, if you enjoy deep dives like this on EV technology and the engineering breakthroughs reshaping the future, don't forget to subscribe and turn on notifications, because you won't want to miss what's coming next in this industry. Just as the EV race hits its most intense stretch. To understand why Musk's latest comment landed like a shockwave, we need to zoom out and look at the bigger picture of the global EV industry over the past several years. About 15 years ago, electric cars were something you'd catch in a short segment on the evening news or see at a tech expo, where everyone nodded politely at the idea, but almost nobody actually pictured driving one home. The batteries were weak, the range was short, charging infrastructure barely existed, and the price only made sense for a tiny slice of buyers. Back then, EVs were a nice idea, but not yet a practical product. Then Tesla showed up, and everything shifted in ways almost nobody expected. The Model S wasn't just an electric car, it was a statement. For the first time, an EV was clean and efficient, but also beautiful, fast, and genuinely fun to drive. Its range crossed a critical psychological threshold. Autopilot got people seriously thinking about an autonomous future, and that giant touchscreen in the dash made the interior feel like it had been pulled from the next century. Tesla wasn't just selling cars, it was selling a vision, and millions of people bought into it. But here's the thing about major markets like the US. Once an idea has been proven possible, the giants wake up. GM, the same company that killed off its EV1 back in 1999 and got heavily criticized for it, started rebuilding its entire strategy from scratch. Ford announced multi-billion-dollar EV investments. Volkswagen set a goal of selling millions of electric cars annually by the middle of this decade. Even Toyota, long the hybrid king, was forced to announce a much bigger push toward full electrification. And that's not even counting the entirely new players. Rivian showed up with powerful electric pickups, Lucid Motors pushed range to record setting levels, and over in Asia, especially China, a whole domestic EV ecosystem is rising at a stunning pace. BYD isn't just competing with Tesla in the affordable segment anymore, it's pushing into premium territory. NIO is building an entire battery swapping network instead of relying purely on charging. Xiaomi, the smartphone giant, just dropped its first EV and sold out within minutes. This is no longer Tesla running solo. And that's the key thing to understand if you want to grasp the weight of what Musk just announced. In such a brutally competitive landscape, with dozens of brands throwing tens of billions of dollars at the same target, Tesla's edge is slowly narrowing. Not because Tesla is getting weaker, but because the rest of the world is catching up to what Tesla built over the past decade. Software, range, charging systems, premium interior design, everything Tesla once had almost entirely to itself is turning into an industry standard. So if you're Musk, watching the pack close in on the old track, what do? You switch tracks entirely. But to understand why this announcement carries so much weight, we need to zero in on the technology itself. What exactly is an electric jet engine, and why is it so different? First, let's be clear. Calling this an electric jet engine sounds flashy and dramatic, but it's actually describing a legitimate engineering concept grounded in real principles. We're not talking about a car sprouting wings, and we're not talking about breaking the laws of physics. We're talking about applying the core operating principle behind a jet engine, merging it with electric power, and creating a fundamentally different kind of propulsion. Here's the simplest way to put it. A traditional EV, including today's Teslas, works like this. A lithium-ion battery stores electricity. That electricity flows to one or more electric motors, and those motors turn the wheels directly through the drivetrain. Simple, efficient, and already proven, which is exactly why EVs accelerate so quickly, since electric motors deliver instant torque the moment they start, unlike combustion engines that need time to build up pressure. But this setup has one fundamental weakness. The vehicle's entire power and range depend completely on how much energy the battery can store. And that's been the industry's biggest bottleneck from day one. Bigger battery, longer range. But bigger battery also means a heavier car, and a heavier car needs more energy to cover the same distance. It's a vicious cycle that's frustrated engineers for decades. And then there's charging time. Even with big strides in fast-charging tech, an EV still needs at least 20 to 30 minutes at the fastest stations to load up enough energy for a long trip, compared to roughly 3 to 5 minutes to fill a gas tank. That's still a real psychological gap for a lot of drivers. Now think about how a jet engine actually works. Air gets pulled in, compressed to extremely high pressure, and fuel is burned to generate powerful thrust, most of which comes from high-speed air shooting out the back, not friction with the ground. That's why airplanes don't need wheels to stay moving once they're airborne. They're being pushed by air. What Musk appears to be chasing is a system that pulls in and compresses air using electricity instead of burning fuel. If it works, this could generate thrust without depending entirely on wheel friction. And here's the interesting part. A system like this could theoretically run on a much smaller battery pack, since it wouldn't need to store enough energy to spin the wheels for an entire trip. Just enough to maintain a high-pressure airflow, which could be far more efficient under the right conditions. On top of that, since some of the thrust would come from air rather than purely from the wheels, the vehicle could hold more stable performance on rough surfaces. Rain, snow, mud, conditions that badly hurt regular EV performance, might be handled much better if thrust isn't coming solely from the tires. At first glance, this sounds like a niche technical detail, but it's exactly the kind of detail that could flip the entire game if it works out. The real breakthrough isn't speed, it's escaping the battery trap. Now we get to the point most people miss when talking about this tech. When people hear electric jet engine, they immediately picture speed. A Tesla launching from 0 to 100 km/h in under 2 seconds. And yes, if this pans out, that level of performance is absolutely within reach. But that's not actually the biggest leap here. The real breakthrough is something EV engineers have been losing sleep over for the past 15 years, breaking free from lithium dependence. Look at the supply chain behind a modern EV. Building a battery pack powerful enough for a mid-range car like the Model 3 requires substantial amounts of lithium, cobalt, nickel, and manganese. These minerals aren't unlimited. They're not evenly distributed around the globe, and extracting them causes serious environmental damage. Cobalt is the clearest example. A huge share of the world's supply comes from the Democratic Republic of Congo, a country already dealing with deep political and social instability, and reports on cobalt mining conditions have shocked the public repeatedly. EV manufacturers, no matter how good their intentions, are still tied to that supply chain, and cobalt prices can swing so hard that a single spike can wipe out an entire year's profits. If Musk really can build a propulsion system that shrinks battery pack size significantly or removes dependence on massive lithium batteries altogether, that wouldn't just be an engineering win. It would be a geopolitical win, a supply chain win, and an environmental sustainability win all rolled into one. A car powered by electric air propulsion would need less battery capacity, which means less lithium demand, which means less reliance on troubled mining regions, and the entire cost structure of EV manufacturing could be rebuilt from scratch. But there's a third factor rarely discussed, and it's the one that could force Tesla's rivals to rethink everything from square one. If the basic propulsion mechanism behind EVs changes entirely, then everything competitors have invested in optimizing traditional battery and motor systems might stop being a real advantage. Billions of dollars poured into next-gen battery research could suddenly turn into investments in a technology that's already on its way to being outdated. This is basically what happened when EVs began truly competing with gas cars. Manufacturers who'd bet too heavily on internal combustion suddenly found themselves holding obsolete weapons in a war that had already shifted. History might be about to repeat itself, only this time with the same companies who benefited from the last shift. Still, no matter how promising a technology sounds, it means nothing if it can't be built at scale. And this is where the story gets far more complicated. Challenges nobody should ignore. Let's be honest, this is the part a lot of Musk-focused YouTube videos gloss over before rushing back to excited praise. But if you actually want to understand this story, you need to look at the challenges head-on. The first and biggest challenge is whether this even works reliably in real-world conditions. The underlying principle of an electric jet engine isn't baseless, but applying it to a real road vehicle, one that has to handle potholes, storms, dust, and the brutal winters of Minnesota or scorching Arizona summers, is an entirely different engineering problem. Jet engines on airplanes get maintained under extremely strict schedules after every few hundred flight hours. A family car needs to run tens of thousands of miles with minimal upkeep, and it can't just fail mid-drive. Compressing air at high pressure demands extremely precise mechanical components, and those components wear down over time. Temperature, humidity, and pollution all affect performance, and any failure in a high-pressure system on the road could create dangerous situations very different from a regular EV simply running out of charge. The second challenge is early production cost. Tesla learned this the hard way with the Cybertruck. The design was striking, but manufacturing it was so complicated it took years to hit meaningful production volume. With a brand new engine technology, the supply chain doesn't exist yet. Parts suppliers aren't ready, and workers aren't trained. Early production would almost certainly be more expensive, slower, and riskier than expected. The third challenge is regulation. The U.S. has an extremely strict vehicle safety approval system, and any new propulsion type has to go through thousands of hours of testing before it's cleared for public roads. With no real precedent for something like an electric jet engine, the National Highway Traffic Safety Administration isn't going to rush an approval, no matter who's asking. And that's before even considering international markets. The EU, China, and Japan each run their own approval processes. Tesla once spent months just convincing European regulators to greenlight certain autopilot features. A completely new propulsion mechanism could take years to clear those same hurdles. Finally, there's a challenge few people say out loud, but it matters a lot. Musk's expectations often outpace reality. He said fully self-driving cars would arrive in 2020, then 2022, then 2023. The robo-taxi rollout keeps getting pushed back. The Cybertruck eventually launched, but years later than originally promised. That doesn't mean Musk can't deliver, he usually can, but it often takes far longer than the original timeline suggests. And with something as ambitious as an electric jet engine, that delay could give rivals plenty of time to respond. Which brings us to exactly why this race keeps getting more intense. Tesla isn't the only one trying to shape the industry's future. Who's standing on the other side of this race? To really grasp why Tesla's new tech matters, we need to place it inside a competition that's getting broader, tougher, and more aggressive by the year. Let's start with China's BYD. Not many people in the US follow BYD closely, but that could be a costly blind spot. BYD is now the world's largest EV maker by sales. It builds its own lithium iron phosphate batteries, a chemistry that skips cobalt, costs less, handles high heat more safely, and lasts longer through charge cycles than traditional NMC batteries. BYD controls much of its own supply chain, from raw materials to finished vehicles, and it's expanding internationally at a stunning pace, from Southeast Asia to Europe to South America. If Tesla changes the basic propulsion mechanism, BYD has both the engineering muscle and the financial firepower to respond fast. It's not just a car maker, it's a massive energy technology company. Next is Lucid Motors. The Lucid Air still holds the record for driving range on a single charge among commercial EVs in the US, even beating Tesla. Not because of some flashy performance trick, but through genuine progress in battery energy density and motor efficiency. Lucid is proving there's still a lot of room left in optimizing traditional battery tech, and that you don't necessarily need to reinvent the whole propulsion system to make major gains. Then there's Rivian, steadily building a loyal following in the electric pickup and SUV space. Rivian isn't chasing Tesla on every spec sheet, instead it's giving people a different reason to buy, built around community, outdoor lifestyle, and everyday durability. And don't overlook legacy players like Ford with its F-150 Lightning or Chevrolet with the Equinox EV. Ford is aiming to put EVs in the hands of practical buyers, people who never pictured themselves driving a Tesla, by blending familiar design with electrified underpinnings. It's a less flashy strategy, but it reaches a customer base Tesla has never fully connected with. So what does this competitive picture tell us? Even if Tesla's electric jet engine really works as advertised, the road to global market dominance won't be a straight line. In today's EV world, better technology doesn't automatically mean a bigger market share. Price, distribution, after-sales service, brand familiarity, and government policy all matter just as much in the final equation. So in the end, the big question remains: is this technology genuinely powerful enough to change the future? What could the future actually look like if this works? This is where we step into possible scenario territory. Nothing guaranteed, but clear enough to sketch out. The first and probably nearest term effect is a shift in charging infrastructure. One of the biggest EV barriers in the US isn't the price of the car or even its range, but the fear of not finding a charger when you need one, especially for people in suburban or rural areas where networks remain thin. If this new tech significantly cuts the need for frequent charging or enables faster charging because total energy needs drop, that psychological barrier could fade on its own, without governments needing to pour billions into expanding charging networks. The second effect touches mining and the global supply chain. If worldwide EV production keeps growing along its current path and every vehicle still needs a battery pack the size of today's, lithium demand could rise to a level even the busiest mining operations might struggle to meet in the near term, a real risk for the whole industry. A propulsion technology less dependent on batteries wouldn't just be better environmentally, it would help stabilize prices and improve long-term production scalability. The third effect, maybe the most interesting one for everyday drivers, involves long-term ownership costs. One of the strongest selling points for EVs is that they're cheaper to run than gas cars, less maintenance, cheaper electricity, no oil changes, no filters. If an electric jet engine really is more durable thanks to fewer friction parts and less heat buildup, then the cost of owning a car over 15 to 20 years could shift in favor of consumers even more than it already has. But maybe the most surprising ripple effect lands somewhere completely outside cars: short-range aviation and cargo transport. Electric aircraft are one of the biggest open engineering questions of this decade, and the core concept behind an electric jet engine actually applies more naturally to planes than to cars. If Tesla and SpaceX end up collaborating on this toward aviation, short routes of 200 to 500 km could go electric sooner than any current forecast expects. A massive market Tesla has never publicly said it wants to enter. Musk has never been someone who focuses on just one industry. He looks at the whole ecosystem. Tesla, SpaceX, Neuralink, The Boring Company, Starlink, every project feeds into a bigger vision of how people move, connect, and survive. If this works, the electric jet engine wouldn't just be a product. It would be a platform other industries could build on top of. And once you zoom out and see the whole picture, it becomes clear why Tesla's rivals aren't just worried about a new car. They're worried about a company trying to reset the foundation of how the world moves both energy and people. We've covered a lot of ground here, from the state of the global EV industry to the technical side of a technology no one's fully seen yet, to the ripple effects that could stretch into aviation and mineral mining. But let me boil down the most important point. What matters about Elon Musk isn't any single invention, it's his habit of choosing the exact moment to rewrite the rules right when the world thinks it already has the answer figured out. The EV industry is at a strange stage right now, established enough to be mainstream, but still young enough to be completely upended by the right breakthrough at the right time. And if the electric jet engine can genuinely clear the technical and regulatory hurdles we talked about, that disruption could arrive much sooner than most people expect. But here's something nobody should ignore. The future is still wide open. The history of engineering breakthroughs isn't just a story about who had the best ideas, it's a story about who could turn good ideas into real products. Deliver them on time, price them right, and get enough people to believe in them to build real momentum. Tesla has done that before, but doing it once isn't a guarantee it happens again. There are hundreds of millions of people worldwide, especially older generations in the US, who've sat through enough big tech promises to be cautious by now. They don't need to be convinced by a statement, they need to be convinced by evidence. And that's exactly what Musk and Tesla will have to deliver in the years ahead. So the final question I want to leave you with isn't whether this technology actually works. It's this: if it works exactly as claimed, what would it change in your life? The car you drive, the electricity bill you pay, the energy sources the country relies on, and more broadly, America's standing in a global tech race that's only getting hotter. That's what I really want to hear your thoughts on. Do you think this is a real turning point, or just another big promise waiting for time to prove or disprove it? Leave your take in the comments. There's no right or wrong answer here, just different perspectives from people genuinely watching and thinking about the future. If this video gave you some new angles to consider, hit like to support the channel. And if you want to keep following deep dives like this on EV technology, energy, and the breakthroughs shaping the world, subscribe and turn on notifications. The race is already underway, and what happens over the next few years could turn out to be the most fascinating chapter this industry has ever written. See you in the next video.